This is a pre-interview introduction on black holes. So the modern scientific consensus of black holes is that black holes are real. Black holes have been classified as an intensely packed huge sum of mass that have a gravity so strong an event horizon is created. An event horizon is a point where not even light can escape. The only image of a black hole is the M87, which is a supermassive black hole. It was detected by a network of telescopes known as the EHT, or Event Horizon Telescope, which were all synchronized to capture this image. Mathematically, Einstein predicted black holes through his general relativity. They were scientifically misunderstood, and most scientists were skeptical as they believed they were impossible and there wasn't enough evidence as you couldn't see them. As time progressed, gravitational wave detectors, synchronized telescopes such as the EHT, and continuously tested hypotheses all point towards the existence of black holes. Some evidence of black holes is the observations of stars accelerating in orbit around an invisible object. Since black holes have so much mass, they make stars continuously orbit faster and faster as they gain more mass. So, measuring the orbiting star's rate of acceleration, they can calculate the mass of the unknown object. If the mass is so large and compact, they conclude it's a black hole. Using synchronized telescopes, as spoken about earlier, you can capture an image of the extremely hot mass that swirls around the supermassive black hole M87, and LIGO detection. LIGO detection detects gravitational waves produced by black holes colliding. It's known as a merger, is seen on the image on the right. And as the black holes collide and merge together, they produce these waves that can be detected. And this is a bibliography of the sources that I used for this pre-interview introduction.
Welcome. So this is today's interview on black holes. I have one of my good friends, Cooper Phillips, here, and I'm just going to ask him a couple questions on black holes, see what he knows, and see if I can teach him a little something. All right, Cooper, are black holes real, and if so, what are their properties?
I think they're definitely real. I don't know why anyone would think otherwise. I don't know, maybe like some flat earther thinks that they're fake, but
Okay.
I think they're definitely real. I think we literally got pictures of them. So their properties, I don't know, they just suck things in.
Okay, so to start off, that's actually a misconception. They don't just suck people in. But the modern consensus is that black holes are real, and they are huge concentrations of matter packed into very tiny spaces, and they have what's called an event horizon, which is a boundary where the escape velocity exceeds the speed of light, and nothing can escape. So they're basically invisible, which is why it's like a scientific skepticality is the best way to put it. So what is a black hole, and how does a black hole form?
Well, I don't know exactly what a black hole is, but I think it's got something to do with stars and like at least how they form. But I mean, I don't know exactly like if it classifies as a star afterwards, but
Okay, so actually they do come from the death of stars. More massive stars, as they die and they run out and they can't do any more fusion, it actually can create a black hole. Black holes are a region of densely packed mass with such intense gravity that not even light can escape it, like I said, the event horizon. Um, do black holes really exist, and what is the scientific evidence for the black holes?
well, I mean, yeah, again, I think they do exist. Scientific evidence, I mean, I thought that maybe we got a picture of one recently, maybe we didn't, but I mean, that's the only real scientific evidence that comes to my mind at least, but
So we did actually get a picture of one. It was M87. It was a supermassive black hole. Another thing is that astronomers can actually observe a star accelerating in orbit around an unseen object, which would be the black hole, as they don't let light escape. So by measuring that orbiting star's rate of acceleration, astronomers can actually calculate the mass of the object pulling it. And if the region is so small and the mass is so high, then we can safely conclude that it's a black hole. In other instances, we also use what's called multiple telescopes actually put together. You kind of use like an array of them, and it's actually called the EHT. It's called the Event Horizon Telescope. It's a bunch of telescopes all pointing at the same place, trying to identify it. And the last thing that we can actually use is called LIGO, and it detects gravitational waves as black holes merge together in what's called a merger. Can anything escape a black hole?
Well, I don't really know. I mean, I've seen in like movies and stuff, like, I don't know, like in space, they'll like jet away. But I mean, I don't know about anything, not from Earth, I don't think, can escape a black hole, but maybe like, I don't know, certain stars and stuff. I don't know, shooting stars maybe.
Okay, so the current scientific consensus is that nothing can escape as the gravity is too intense at the event horizon. And the only inability we do have is we cannot see what's in the black hole. We can't see what the matter looks like, can't see any of that because, well, we can't get inside the black hole. That is still actually a mystery of space. What would happen to the sun? What would happen if the sun suddenly turned into a black hole of the same mass?
Well, I think if the sun turned into a black hole, we'd probably all die.
Okay.
Either from being sucked, or I guess not being sucked in, or depends how close we are. But I mean, if the sun dies, we don't really have heat, so.
So that is actually true. Earth's temperature would change, but the orbit itself of Earth would actually not change due to the fact that that's not big enough. It wouldn't change the orbit, but it definitely, the temperature would change, and there would be no solar wind or solar magnetic storms. But we would not be sucked in because black holes are not cosmic vacuum cleaners. So what do you think would happen if a human fell in a black hole?
Well, I mean, the gravity's super intense there, so I'd probably say they just get like squished up or something. But yeah, I mean, I don't think we really can know right now.
It's actually quite the opposite. It's called spaghettification, and it's actually where it's crazy. The body would actually be pulled, and all the atoms in the body would be pulled into a line as the gravity literally pulls you into a line of atoms and stretches you apart. And as they actually get closer, due to general relativity found by Einstein, time would get slower. And once they were spaghettified, the whole universe would flash before their eyes, the whole future. And that would be it. And that's it. So let's go over some misconceptions of black holes. Black holes suck up everything. No, they can consume an object if it passes within the event horizon outside the radius. Their gravity works like any other object with mass. They don't just suck in everything. Another misconception is black holes are holes or empty space. And no, actually, black holes contain a huge amount of mass squeezed down into a tiny space. So actually anything can become a black hole, believe it or not. Even a human, if you squish it down into a densely packed space enough, it can actually become a black hole. Another misconception is black holes are invisible and do not emit any light at all. And no, while light cannot escape the event horizon, black holes are surrounded by a superheated disk of gas, which is called an accretion disk, and it emits X-rays, light, and radio waves, making them visible to telescopes. And that is when you were talking about that picture, the M87, that ring around it is that accretion disk. So we went over some misconceptions. The scientific consensus has changed a little over time as technology has advanced. And while people were skeptical before, scientists were skeptical before, it has began to become more of a, I mean, it like accepts hypotheses, many hypotheses, and it makes so many things possible with black holes being real. So, Cooper Phillips, I do appreciate your time today. I hope I gave you some good knowledge about some black holes, and I appreciate you giving me a minute.
Yep.
So, post-interview, just wanted to go over a little bit more. Some extra information is supermassive black holes are at the center of most galaxies, including our Milky Way galaxy. The light produced by the accretion disk is the light seen going above the black hole, and this is in this scientifically depicted image. And this is due to the light flowing, following the general relativity guidelines as light bends with gravitational wells. Because black holes have so much mass, they create a gravitational well, and light bends with these wells. That's what Einstein figured out. The Schwarzschild radius, also known as the event horizon, it strictly depends on the mass of the black hole. Going over some changes, shifted from viewing them as purely mathematical and possible curiosities to recognizing them as physical, common, and crucial engines of the galaxy evolution. So this is basically just saying that black holes used to be viewed as just like Einstein's math, that was it, like. And now we're starting to realize that like they actually play a major role in galaxy evolution and our galaxy specifically as we all orbit it. Once it was figured out the supermassive black hole was at the center of our galaxy, it became near impossible to deny their existence. I mean, we all realize that stars are going around, like astronomers figured out the stars are going around this galaxy and our solar system is going around this galaxy. A fun fact is it is very challenging / impossible for dark matter to form black holes, and this is due to dark matter's really hard to reach this condensed state to form said black hole. It's kind of weird that dark matter explains missing information about our galaxy and the universe, yet they have nothing to do with black holes. Thank you for watching. This is my Astronomy 100 project, and I appreciate everybody's time for taking a look at this.